Okay, welcome to our talk, and thanks for joining. So the next 35 minutes, round about 35 minutes, we'll try to talk about next-level Kubernetes networking with Cilium, and would like to show you different pieces you can do with Cilium, not only network policy, but all the other stuff, but we'll talk about this in just a sec. Yeah, some words on us.
So, hi everyone, my name is Philip, I'm at White Duck, obviously, and I'm a senior Kubernetes and DevOps engineer, doing all the stuff, Kubernetes, automation, CI/CD, daily, and yeah. Good for you, only 2 sessions, then we have beer. So we try to be fast.
Yeah, my name is Nico, I'm Cloud Solution Architect and also helping our customers running or bring their workload, cloud native workload to Azure. Yeah. Now the agenda for the next 30 minutes, we're starting briefly with a Cilium eBPF introduction, but really just the baseline to get everyone on the same level. And then Phil will start with Zero Trust networking and observability with Cilium CNI and Hubble. And afterwards, we'll see how we can connect multiple clusters with Cilium cluster mesh to really shift around workload on different clusters. Then going a level higher on the application level, let's say, and doing application-centric networking with Cilium service mesh, so routing our traffic from one cluster and one application to another, and then sum up the day with Cilium mesh, one mesh to connect them all, to really to see, okay, how can we integrate any other workload into our Cilium mesh. So this is basically what we will talk about. Starting with Cilium eBPF introduction. And here starting mainly with eBPF for the start. So you can talk about eBPF the whole day, really just a quick sum up. So basically eBPF allows you to extend your kernel with your own code, and this code is completely sandboxed, running secure next to your kernel, and then basically we can hook into a specific event, so we'll talk about this in a second, to then run and schedule your specific code you would like to run. So basically, it's what JavaScript is to our browser, is basically eBPF to our Linux kernel. So we can securely configure things to run on specific events. So for example, we have a process status relies on a syscall in our Linux kernel, and then we can hook in our eBPF code, our application doing something. And basically, this is what Cilium and all other tools relying on eBPF is doing. They're really then running specific code on specific syscalls in this example. But it's not only about syscalls, so it's basically, again, running your application on specific events, and those could be any attachment points here. So we have kprobes, kernel functions, user space functions, so on the user level side, syscalls as mentioned, Linux trace points, if there are some. You can hook eBPF programs to sockets, to your network devices, your disk, and so on. So you basically have multiple options to really hook in with your application code running with eBPF. And this is basically the whole, in easy words, what Cilium is doing on the specific layers. So talking about Cilium and the things we would like to focus today. So Cilium at all is eBPF networking, observability, and security. But we have specific parts we can rely on. First of all, we have Cilium Container Network Interface, CNI. I guess this is the part most people already using or have seen. So maybe hands up who's using Cilium to manage their networking. Oh. A few hands, okay. Hubble then helps you to see what's going on in your cluster, to get the observability. We will see it later. And then we have Cilium Mesh to connect the whole world. We have cluster mesh and also service mesh on the application layer, as I said. But we're not focusing on today is Tetragon, so the security part for runtime security, container runtime security. This will be covered in our talk tomorrow morning. And we will also not cover, except on one side, any Cilium enterprise features. So everything you see today, except one thing, and I will mention it, is completely open source, and you can really use it with open source Cilium. Yeah. with this, we're starting in, and Phil will start with CNI and Hubble.
Yes. The Cilium CNI basically is the core, as Nico mentioned, of Cilium. So the CNI helps us with network policies. I think you know it. We have service and load balancing network side. We have flow logging, policy logging, so metrics basically. We have this enhanced networking speed, which we'll talk in the next slide. It completely abstracts the kube proxy, so it's one daemon set. We also took a look. We have advanced network policies, layer 7, layer 4, layer 3. We have traffic encryption with WireGuard, it's also new. And we have the load balancing features and networking, basically. So it brings Cilium CNI. And what is Cilium CNI on Kubernetes? Basically, it's an agent and the Envoy proxy. In the default at the moment, the Envoy proxy and Cilium agent are running in one daemon set together, as you see on this left side. So what does it do? It's deployed on every node, daemon set for sure. It injects the eBPF program into the node. It helps us with load balancing. All the network stuff is done by the Cilium agent and the Cilium identity, which we will also talk in a few seconds. And when you run a daemon set with the Envoy included, whenever you call a layer 7, for example, stuff, the Envoy proxy starts as a separate process inside the Cilium agent. And with the new mode, I think it's released with Cilium 1.15, you can deploy Envoy as a own daemon set, which would basically load balance a little bit the traffic, so it's not on one pod only. You have to rely on both, and the spread radius when something happens is a bit more distributed. And the Envoy proxy also takes care of the whole Ingress gateway API implementation in Cilium. And as I said, it will be the default mode with the next releases. It's expected to be. And what is the Cilium identity, what we talked before? The Cilium identity, basically, if you know normal networking from before, so when the pod starts, all IP tables has to be written. It's a little bit of delay process because new pod starts, gets IP assigned, IP tables has to be written. And this is completely abstracted with Cilium because Cilium relies on an identity. So it's called identity-based network security. Basically, every pod gets when the pod starts, it gets the identity assigned by labels. And whenever this replica set or deployment or whatever scales, all pods with the same labels get the same identity basically directly assigned. So you don't have any delay of IP tables. And especially when you have a massive scale and large deployment, it decreases the deployment time really fast. Then we have this API-aware authorization. As I mentioned before, the network policies, we have layer 3, which is on IP. We have layer 4, which is basically the port, so TCP. And then we have layer 7, where we can also block direct API calls. We will also show it in the demo. Basically, this is here also just a small example. I hope you can see it good of a layer 7 policy. Basically, we allow ingress to labels and to the port 80, and then we just allow the path /public with the get method. This is basically layer 7 policy in Cilium. We have also DNS-aware Cilium network policies. There's the DNS proxy from Cilium, which runs inside the Cilium agent. And when you configure the policy, the Cilium agent will make a DNS request to a specific host name, records all the IP responses, and to the network policy, only those IPs which recorded are allowed with the network policy. So this is how Cilium handles these DNS policies. Then we have the Hubble UI, or the Hubble CI and UI, which helps us with observability, so we can make traffic visible. We will show it also, so don't much to talk about, but it comes with Cilium. And what we do in the demo, we will apply some network policies, observe network traffic with the CI and UI, just that you see it. We will inspect a little bit the Cilium identities, so that you can see what is happening there. We will create layer 3, layer 4 policies, and also a layer 7 policy. Oops, sorry. Okay, flip. Can you see it? Is it okay? Or too small? Okay, perfect. So what I already did, so prerequisites is we do the Hubble port forward, that we can use the Hubble. We created the namespace demo, and we deployed, there's a nice demo application provided by Isovalent on Cilium. It's basically the Star Wars demo. And what the demo does is, it deploys the X-Wing, the TIE Fighter, and the Death Star deployment, basically Star Wars. And what we can do now is, wait, let me get a bit here. We can do nice API call. So we're using the TIE Fighter, and we're calling the API that we're requesting landing on the Death Star. As you can see, ship has landed. And also when we now use the X-Wing, which basically should not be allowed to land on the Death Star, at the moment everyone is allowed. And now we can observe, I will make it a little bit bigger here. This is the Hubble CLI. You see what's happening there. So here's a lot of forwarded traffic and allowed traffic basically to the Death Star. What you can see here nicely is that here you see already the Cilium identity from which the traffic was directed to the Death Star. So basically we have here two identities. We have the TIE Fighter and the X-Wing. Oops, sorry. And what we can now do is we can use the Cilium CRD. So we can use take a look at the identities. Hope it will look good now. No, it doesn't look good. But basically, this is a list of all identities in the cluster. It's via CRD, so you can easily look at it. And what we want to do, I go just here and grab the TIE Fighter identity, and then. Oops. And then we make a little bit YAML output, because it's a little bit more handy. What you can basically see now is that the identity we just grabbed has those labels assigned. So, oh god, sorry. Every pod with this label now will get the same identity. So it immediately takes the identity and get all the policies assigned. But we don't have any policy now. So what you can also do, I hope it's not me. What you can also do, you can use the Cilium agent and do the same. So just a quick overview for you. So basically, we are calling the Cilium agent here with the container Cilium agent, and then we make a Cilium, use the Cilium CLI basically, and do identity list. But we don't do the list now because we know our identity already. So I just grab this and my identity. And it basically shows me the same, the labels which are assigned to the identity. Okay, we can do the same in the Hubble UI. So when I switch now, when I find it, no, where is it?
You minimized it.
Is it which browser is it? Chrome?
On the right.
On the right, okay. Ah, here. Yeah, I got it, sorry. Basically, we have the Hubble UI, more handy than the CLI. When we create the demo namespace, we will see the traffic which is going from the X-Wing and from the TIE Fighter, basically the same, but with the UI. And what we do now is we create a deny all policy, do our same calls. I just quit them. Yeah, you see this drop now because we created the deny all policy. I can also show you the policy in a few seconds. Do the same from the X-Wing. Should also not be allowed to land, and then we see also the dropped comments. So we made the drops and the access now visible. And we can also inspect the policy. Oops. Basically, it's a default policy, which denies every traffic to the labels class Death Star and Orc Empire. What we're going to now, we create a layer 3 policy where we allow traffic to the pod now. Where is the policy? 1 second. It's this one. And what we do, we have the same. We every endpoint which has the display of labels, and now we allow traffic from the pods which identity basically, but the pods which have those labeled. Sorry, my voice is a little bit. I'm losing my voice today. Okay, but it's clear. So we allow the traffic now only from the TIE fighter and not the X-wing. So. And now, when we come from the TIE fighter, we should be allowed to land on the Death Star, because we are from the Empire, and we are also testing the X-wing, which is from the Alliance. But should I get a timeout? As you can see now here. So traffic from the TIE fighter was not allowed. The X-wing was not allowed. That is what we want. Okay. But now, as you know, that where is it? I lost my. I skipped this. Okay, but as you all know, if I look Star Wars, the Death Star has a vulnerability, and what we do now is we make the layer 7 traffic visible. Therefore, we use this command here. We just annotate the pod. It's proxy Cilium, proxy visibility, and we define egress from that pod to port 80 TCP and the HTTP protocol. So this is like here, this line. The traffic direction, the layer 4 port, layer 4 protocol, and layer 7 protocol. This is how the annotation has to look. So I do this now. Pop. And what we can do now, we can go as a TIE fighter again, request landing. And we can also make use of the Death Star vulnerability. As you can see, ship is landed. We exhaust the port now, and you see Death Star is exploded, like in the movies. So when we go back to Hubble, what we now see here, as you can see the commands. We did a put on the exhaust port now, and here, a little bit down, we have the post to the request landing API. So we made it visible now with the pod annotation, and gives us a little bit more flexibility. And what we then can do for sure is create the layer 7 policy, as we talked about. So we will create the layer 7 policy, which basically allow only the path request landing with the post. So every other API or every layer 7 traffic is blocked now. Go back here. So as expected, the ship. Oops, sorry. The ship can land now, the TIE fighter, and the exhaust port has an X69 by layer 7 MY proxy network policy. So the Empire will survive and will rule the world, basically. And what you can also do, one thing more, we can get the policy get. So with the Cilium agent, we can make the identity. I don't know if it looks good now, but we can see on this node basically the whole Cilium network policy, what is injected on the node. So this is the JSON object, how it will look on the node. And for every policy, you have a big JSON and can look at the policy what's applied on the node. And then we can also take a look at the policy selectors, which will show us, we can see it here. We have a selector for that label. So basically, this is the policy which will apply to this identity here, because we have the layer 7. So you can use the Cilium CNI on the nodes to make that visible, what policy applies to which Cilium identity. And that makes us a little bit more, add more visibility in our network stack now. And also when you go to Hubble here and click, for example, select the TIE fighter, you will recognize that in the above field, I don't have a laser pointer here. Is it working? No, huh? Yeah, basically, the selector above for the pod is not the pod, it's the identity always. So Cilium works really on identity level, on the Cilium identity. Okay. Then we go on with cluster mesh. Cluster mesh helps us to add high availability and fault tolerance to our clusters. We can use several clusters, connect them together. I have to be a little bit faster here. So we have transparent service discovery. We have shared services across clusters. We also show it, and we have this effortless IP routing. And the big picture basically is we have several clusters, or two in this case. We will create a service on the left cluster. We have to create a service on the second cluster again with the same namespace, with the same name. And then we can make this high available. Sorry. And basically, this is a simple scenario where we add just high availability. We have a deployment here, deployment there. We have the backend service, all have the same name. And when our both pods die here, the backend 1, backend 2 on cluster 1, the traffic will be directed to the second cluster. What we can also do is network affinity, where we specify that the services are local until this route here becomes unavailable and automatically switches directly to the other. So we can really annotate this. So every service needs to be marked as global. And then we can make affinity, use local or remote until the route becomes unavailable. And we can also do the advanced scenario where, for example, we have two stateless clusters, one stateful cluster where we redirect all the traffic, which has to be where state need to be saved in this one stateful cluster where we have, storage attached. Yeah, we can also create Cilium network policies across clusters. So we can allow to the Rebel base, we can create a policy that is allowed from cluster 1 or cluster 2. So we can really make our traffic flow how we want it. Just a small demo. So as I mentioned, we have the application deployed in both clusters, same name, same namespace. We make them as global, and then we will scale the replica set down to 0, and the traffic will be redirected. Okay. Cluster mesh. 1 second. Okay. So again, we use a Star Wars demo. It's called the Rebels demo. So what we basically did is we can make a call on cluster 1. Yeah. And then we get an answer, hopefully. Or not. Or yes, I don't know. Or not. Maybe it's slow. Let's block. 1 second, just check if there's a Cilium network policy here, except the other one. No. Thank you. Okay. I know. Maybe it's slow, or I don't know. Oops. Is it the pot? The pot is here. Demo gods are not with me today. Or maybe it's just slow. Can help me. Just give it some seconds. Okay, we have to skip this demo, I guess. So. But you will see the cluster mesh in the next demo for Nico, so if it will work. Okay. Then it's your turn.
Yeah. So as Phil let me 5 minutes left for the second half of the talk, I also have to speed up a bit. So basically next is about the application-centric part. So really not talking only about bring the applications across cluster, but also to route your traffic between different versions and so on. So with this, you are pretty flexible. So you have multiple options on the control plane side. You have multiple options for observability. You can basically put in OpenTelemetry, Prometheus, all the things you would like to. On the control plane side as well, you can use the Ingress resources as you know it. You can use the new gateway API. You can rely on Istio if you like to. And if you're really complex use case, you can also just go with the Envoy CRDs and really define how your application should be routed with Envoy directly. So different options on the control plane, also on the data plane. Phil already talked about there's a new and an existing option. The existing option really relies on Envoy being added on the sidecar for layer 7 traffic. The new world starting soon really relies on a sidecar-free Envoy, so you have really Envoy running in your cluster, which is used to route all layer 7 traffic. Everything else is eBPF native. Yeah. So with this, you basically have a reduced complexity because you don't need specific tools. You just have one tool. You don't need an Ingress controller or something in place. So it's basically everything within Cilium. As I said, sidecar-free routing, at least based on a control plane. If you go with Istio as a control plane, of course, this currently still relies on sidecars. And you're pretty flexible. So everything between IP, TCP routing, UDP, HTTP, for example, Kafka, gRPC, think about routing, gRPC traffic, and so on. It's everything supported. And the underlying part is, once again, as Phil already mentioned, the identity-based security or identity-based security from Cilium here. Which is pretty nice because talking of sidecars, so this is basically the normal behavior. Your app is talking to the lookback device. This is talking to any kind of sidecar proxy. This again talks to the virtual Ethernet port and then the whole TCP stack until it's really on the Ethernet port here. On the right side, it's layer 3 or layer 4 routing. So it's really the pod talking directly through eBPF to the network device, and there's nothing in place. If you opt in for layer 7, of course, we still have the service mesh proxy on the right side. There's another hop, but only if you rely on it, which is pretty great and good for performance. So what can you do when you combine cluster mesh and service mesh is this here. So we have two clusters. We have on the left side an Ingress. In the demo, it will be a gateway API, but doesn't matter. And basically, most of the traffic is routed to the front-end service version 1 to the backend, and 1% is routed to the second version, where also is another review service added, which then goes to a backend service, which only lives on cluster 1. So this is basically service mesh in the app and cluster mesh down. And this is basically now what you will have a quick look in the demo, a really quick one. So let me clean this up and go to the service mesh. So I already created two namespaces. So first is we need to apply the gateway configuration. If you're not aware of gateway API, it's basically the new Ingress.
In the wrong directory.
Oh, I'm in the wrong directory, you're right. Service mesh. So basically, just telling, hey, we would like to get an HTTP on port 80, and basically all routes from the same namespace are allowed. Nothing more. So then we have a deployment on cluster 1. This one is basically just a service and a deployment, which basically just shows one sample application. Basically, just that one, a UI running one deployment, nothing more here. So quickly, sorry, let me make this small. So quickly deploying that one. And then this is the cluster 1. And now we're talking about cluster 2. So cluster 2 has another version of this application. So basically, we have a front end and we have an API providing the text we will show on the front end. And basically, as the whole ingress traffic goes over cluster 1, we also need to create those services on cluster 1. And this is basically the servant for the front end, which is once again global and affinity is remote. And the same for the second service, which is basically for the API here. So we're quickly deploying that one here. And then we, of course, also need to deploy the application. So this is basically, once again, the service. As we're on the second cluster now, it's local. Same for API. And then we have 2 deployments, basically one the front end, one being the API. Doesn't matter now. So, and if we now go into the browser and reloading, we're seeing version 1 all the time. And the nice thing is now that we can go to the root, HTTP root configuration here. And here we're defining the prefix, we're defining the services, and we have a weight here. So for example, currently we're on 100% on version 1, and we can now do a 50-50 here, for example. And just doing a apply here. And now basically we have 50-50. Basically mean 50% will be routed to the cluster 1, and 50% will be routed to cluster 2 with the version 2. So basically ingress from cluster 1, and then application gets served on the different clusters on a 50-50 level here. Yeah. So basically, as you see, it's also really, really nice to get control, how to route your traffic. When you deploy a new application, you can start with, I don't know, 5%, 10%, check your matrix, if everything is fine, then basically scale out. So last but not least, and it's really, really fast, is Cilium Mesh. And I will just put up this slide here. Cilium Mesh is about connecting all the worlds together. So we have the Cilium mesh here in the middle, doing networking, security, identity, observability. And then we connect Kubernetes cluster with Cilium enabled. We have a so-called transistent gateway, which connects, for example, any serverless workloads in the cloud, connecting any virtual machine on your on-premise data center, any other cloud. So really bringing all the different pieces, networking together in one world, which is really, really nice. And then you can really route your traffic and have all the things you showed you, not only Kubernetes cluster on different clouds, on premises, hardware, Kubernetes, doesn't matter. So this is the only part where I have to say, here is a little bit of Cilium Enterprise included, and it's basically the transist gateway. So every time you need the transist gateway, this is a Cilium Enterprise feature. Everything all is still included in the open source world. Okay, so sorry for that. The end was a little bit fast, but all the demos are on our GitHub. We also included the links to get started. And we also would like to thank Isovalent for the graphics and the bees to make this a little bit nicer here. Yeah, with this, another shout out to Ray doing tomorrow from Isovalent a session on Cilium Grafana, doing deep dive, and Rebirth talking tomorrow morning about how to prevent your cluster from being hijacked or from being hacked. So if you would like to see some container Kubernetes security stuff, I don't know which room, K6 or so, tomorrow morning. Okay. Yeah. And with this, I would like to sum up because we're already being late. Thanks for joining, and if any questions, feel free to come by to us later or tomorrow or so. Thanks.
Yes, thank you guys so much. Well, you just in time, so you actually did pretty good. So I did get 2 questions on Slido regarding the slides, actually, because some people would like to play this presentation again at .25 speed. So, so are the slides on the GitHub as well, or not? And can you pull up the GitHub slide again so people can take a picture so they can use the link later?
Yeah.
So, yes. Yeah, so
the first one.
If you want the slides, just take a picture and you can use them when you get home tonight or tomorrow or whenever. Great. And then from here, I want to thank you guys again. for a great presentation. And you, for the audience, enjoy the rest of the day. One last session, and then the bears are on in the beer garden.
Thanks.